cosine of 7 pi divided by 4. So what we're going to do is, what we notice, ladies and gentlemen, is we have a composition of our function. All right. So what we're going to want to do is we're going to kind of work through this, and we're going to first find the cosine of 7 pi over 2. All right. So we're going to kind of work inside out to complete this problem. So first thing, let's find the cosine of 7 pi over 2. And if you guys remember, when we found the cosine of 7 pi over 2, what we did is we graphed the angle and found out where the angle was on the unit circle, and then found the x-coordinate point to evaluate, right? So let's go and find where 7 pi over 2 is. Well, we're going to go over 2, so here is 2 pi over 2, right? 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Does everybody agree with me? That's the angle of 7 pi over 2. So we look at this point, and we have a point of 0, comma, negative 1, right? So what is the cosine value at 7 pi over 2? 0, right? So we can now say arc cosine of 0. So now we need to find the inverse cosine of 0. But here's our problem. All right, well, not really our problem, but what we need to say is we're going to say now the inverse of 0. So if I said what is the value of the angle when cosine equals 0, you can't simply say that it's going to be back to 7 pi over 2, because remember when we talked about finding the inverse of functions, our angle had to be within our range. And does anybody remember the range for cosine? Trevor? Thank you for giving us. That's for sine and for tangent, was between negative pi halves and pi halves. Very good. Tajay, do you remember cosine? Starts with a 0, ends with a pi. Yes? 0 to pi, right? Very good. So is there another angle between 0 and pi that would still have cosine equals 0? Pi halves, right? If we just did this angle, this is still cosine. Does cosine still equal 0 at pi halves? Yeah. So therefore, we're just going to say equals, our original answer equals pi divided by 2. Ta-da.